Okay, physical science students, let's look at Chapter 8. Um, we are going to continue to prepare ourselves for our upcoming test. Chapter 8 was all about solutions. Okay? And as we talked about solutions, we talked about dissolving a solid in liquid. It could even be a gas in liquid, like a carbonated beverage. And then we talked about how acids and bases are solutions. So let's start, first of all, with what we mean by a solution. Okay, for us, a solution is basically a mixture, and it could be a solid. Here's some examples. Solid dissolved in a liquid, like salt in water or sugar in water. It could be a gas dissolved in a liquid. That would be like a carbonated beverage. It could even be a gas dissolved in another gas, like our atmosphere has a mixture of gases. It could be a solid and another solid mixed together. Those are called alloys. Okay? So it doesn't just have to be a solid in a liquid. That may be a common one. And gas in a liquid may be a common one. But it's a mixture of two or more things that make up our combination. And a solution basically is going to be, it's said to be uniform throughout, meaning it doesn't have inconsistencies. It's pretty uniform throughout. Okay? So let's take, for example, salt water. Okay? If we have salt water, if you had a chunk of salt here, and it is made up of positive and negative ions because it's an ionic compound, sodium and chlorine. Sodium gives a positive ion, chlorine is a negative ion. That's what makes it. They come together, they're bonded together. That salt, if you put that into water, what happens is that salt goes into the water, and the water molecule is designed such that it has a positive end and a negative end. The oxygen side is more negative, the hydrogen side is more positive. And as I mentioned, this sodium and chloride, they have charges on them. So when you put that in there, what basically happens is the water is going to be attracted to these charges. In fact, what happens is the negative end of the water is going to be attracted to the positive sodium, and you're going to surround that sodium with water. And it's going to be the negative end, the oxygen end of the water, that's going to be attracted and surround the sodium and pull it away from the chlorine. What's going to surround the chlorine? Still water, but it's going to be the positive side of the water that's going to be attracted to the chlorine. It's going to be the hydrogen side of the water that's going to be attracted to the chlorine and pull it away from the sodium. So here you've got your chlorine negative, this is the positive side of the water. So both of them, the sodium ion and the chlorine ion, the chloride ion, get pulled away from each other because the water molecule is going to surround it. Okay, water has a positive and a negative end to it, so it can do both. The maximum amount that you can dissolve of some solid or something in a certain amount of water, that is called the solubility. Okay, the solubility is basically the maximum amount. I'm sorry, max amount dissolved. And if you remember, we gave also a word for that. The maximum, when you have the max dissolved, that means the solution is saturated. Okay? The max is dissolved. And you would know that because if you add more salt or more of the solid or whatever you're trying to dissolve, it will not dissolve. You'll have crystals at the bottom that are not dissolving. Unsaturated means that you can still have some dissolved. It hasn't reached its maximum yet. Okay? More can dissolve. If you put more salt into the water and it keeps dissolving, then it's still unsaturated. And then if you remember, there was also a supersaturated solution. And what happens there is it is saturated, and you keep putting more in. So what you do to dissolve those crystals that are not dissolving is you heat it up, then they dissolve, and then you cool it back down slowly. Okay, so it actually is going to be holds more solute than it should, because you heated it up and then you cool it back down slowly, and it might stay dissolved. Okay, we should probably backtrack a little bit here and just define some terms. We talked about solution. Well, the solute is what is being dissolved. Okay, and then the solvent is doing the dissolving. So in our example with salt water, the solute would be salt, and the solvent would be the water. Okay. We did talk about things that speed up the dissolving process, just kind of like a chemical reaction. We did a lab on this, and remember, to help things dissolve faster, increase that rate, we could stir it, we could heat it up, we could increase the surface area, and those were some things that we talked about that increase the dissolving process, speed up the dissolving process. Those are things that we can do in order to make things dissolve faster, and that's intuitive. You guys know that already, even before we did the lab and the experiment. Okay. All right. Then we talked a little bit about specific types of solutions, namely acids and bases. And we talked a little bit about their properties. We talked a little bit about some of the things that you can use to measure how acidic or how basic something is. Okay. Oh, let me make one more comment here, ladies and gentlemen. For heating something up, that will increase the solubility of only a solid in a liquid. Okay? When you heat it up, you will be able to dissolve more solid in a liquid. But if you're trying to dissolve a gas in a liquid, more gas will dissolve in liquid if you cool it down. Okay? So cooling down the liquid increases solubility of a gas in a liquid. Okay, I'll give you an example that you're very familiar with. If you have your bottled beverage here, okay, oh, that is a weird looking bottle, but that's my bottle there, okay, and if you take the cap off of your drink, you know that if you let this sit out and let it get warmed up, a lot of the fizz is going to be out of it. As it warms up, it's going to have less fizz in it. So you keep it cool because it keeps the gas dissolved. The other thing that helps keeps the gas dissolved is increased pressure. If we put more pressure on the gas, and that's why when this is bottled, it's bottled under pressure, okay? So cooling down increases the solubility of gas in pressure, and higher pressure also will increase solubility of a gas in a liquid. You know that when you take the lid off of a carbonated beverage, you hear the sound, and that's basically the gas that's escaping because it was under high pressure, and then you open it up and now it's under a lower pressure, and it's not going to keep as much of the gas dissolved in the liquid. Okay, so cold beverages and beverages under high pressure. Keep that in mind when you're thinking about a gas that's dissolved in liquid. Okay. Okay, on to acids and bases now. Let's talk about acids and bases. We talked about some of the properties of acids and bases. here's what I would like you to do right now. I want you to pause this video, and I want you to look back in your notes or back in the book, and I want you to look up the properties. What are the properties of acids and bases? We talked about these in class. It might be in your notes, or you can look in the book, but I want you to list as many properties as you can come up with right now. Pause this video and come up with a list of properties for the acids and the bases, and then restart this video and we'll finish it up. Okay, hopefully you got your properties for your acid and a list of properties for your bases. You should have that in your notes. Okay. The one other thing that we talked about is, and this would be one of the properties, hopefully you have this in your list, but an acid is going to produce the H plus in water, or also called H3O plus, hydronium. That H plus often is in the formula, like HCl, there it is. H2SO4, this is an acid, there's the H. HF, there's the H. Okay, so this is going to produce H plus when it dissolves in water. A base, you're going to often see an OH, sodium hydroxide. Okay, magnesium hydroxide, there's the OH. So this is going to produce the hydroxide ion in water. That's one of the properties that you must know. We can measure the concentration of this H plus or hydronium ion, and when we do, we give it a number. Remember, we did this in the lab. We used indicators and pH paper to do this. So remember, we have a scale from 0 up to 14. And that scale is going to help us determine the H plus or the hydronium ion concentration in the solution. Okay? So it goes from 0 to 14, and if it is 7, that's neutral. 7 is neutral, and that would be like water. Water has the same amount of hydronium ions as hydroxide ions. Up here, if it has more hydroxide ions in it than hydronium, then it's going to be basic. If it has more hydronium ions, or the H plus, than hydroxide, then it's going to be acidic. Okay? So low pH, pH below 7 is acidic, pH above 7 is basic, and 7 means it's neutral, like water. Okay? All right. So you have to know about the properties of acids and bases. You have to know about pH scale. You have to know that the acid produces the hydronium or H plus in water, and the hydroxide is produced by a base. Okay. You don't need to worry about indicators. We did a lab on indicators, but you don't have to worry about the indicators. Okay. But certainly understand that an acid is a solution, a base is a solution. Okay. One other thing I'm going to add here is that when you combine an acid and a base, when those react, it'll always produce a salt and water. Okay, so we can add them together and kind of neutralize them out, and you're going to create a salt and water. Okay. All right, so that's chapter 8. It was all about solutions. Certainly, if you have questions, please let me know. Otherwise, you can look back in your notes, look back in the book, and just use this video as well to review.